Unless one probability. I can find the probability of an event.
Are we like feeling much better about finding the probability of events?
Yeah.
How many of you feel like you learned at least something today? That's awesome. I'm going to skip through some vocab and just pick and choose. Experiment we're cool with. Trial. Just repeat after me, or just read the definition. Trial. Go.
Number of times you do an experiment.
Are we going to call results, or should we call them outcomes? I like outcomes. Sample space is a big one. If I have an O and an O and an X, what is my sample space? Everybody. Those are all of my possible choices if I were going to choose one of them. Wonderful. Excuse me. An event would be actually the thing that we're looking for. So if I'm flipping a coin and I want to see how many times I get a head, the event that I'm looking for is the head. Probability, the formula, you've been working with this all year. On the count of 3, I want the long version. Go. 1, 2, 3.
Number of available outcomes over number of possible outcomes.
Make sure you understand the difference between impossible, certain, unlikely, and likely. They're very self-explanatory. A fair spinner means it's going to happen an equal amount of times or a fair amount of times if it is split or because it is split evenly. This is new to you guys, you told me. So if we have a capital P and inside of it we have some words, what does it mean? Someone just tell me what that means. Somebody, Brandon, go.
The probability of the event inside the.
Good. So this means the probability of whatever the event is inside the parentheses. So on the spinner, what is the probability of the event of the spinning an odd? Everybody.
1/2.
1/2. 50%. 5/10. What is the probability of this event, everybody?
Impossible.
Can you spin a number less than 1? No, so therefore it's impossible. Are we cool with the capital P in the parentheses? We'll see that time and time again. Number 12, I'm not going to talk through this one very long. Set up your proportion. Proportions are not going to go anywhere on you ever. So set up your proportion to answer the question. And then number 13, again, I would read through this one just to make sure you're clear on what you're doing here. We talked about on a word problem, assign your variable. So you guys said the variable was x equals, who are the people that were x again?
Gianna, Brendan, and
Ella, Gianna, and Brandon. And for those of you that have not seen these notes yet, you're going to have to read through that problem, and hopefully that helps make sense. All of these people have a chance of winning a race. So we added up the probability of Elizabeth, Jay, Danny, Brandon, Ella, and Gianna. And 1 means 100%, doesn't it?
Yeah.
Okay. And then we wrote down what we knew. The 3 people we didn't know were X, X, and X. Philip and Ella did a great job of this. They solved it using algebra. We knew that all of this data added up to 7/10. We combined our like terms on X, X, and X and got 3X. We set it equal to 1 whole, which is 100%. And then you did the easy part, which is solving algebraically. We've been doing that all year. The only thing I didn't do was actually answer the question. So to answer the question, should you tell me what the probability is that Elizabeth will win the race? Yes. Should you tell me the probability that Jay would win the race?
Yes.
So the only thing I didn't do was list them all out because we were running out of time, but you must answer the question, obviously, at the end. Questions before I stop?